Hey folks, and welcome to a new video. So this is a continuation of a short video I did a while ago where I talked about writing code to connect directly to a GRBL device, and I released some source code, very rough source code, and I mentioned that I was working on a bigger project, and this is it. This is the demo of it. So this is the first part. So this project I was working on kind of in the background while I've been really busy recently in between moving house and doing other things. I was able to basically largely just do it on my computer. I didn't need a lot of stuff. I could just kind of write code and get a thing doing and, satisfy some of my urge to build stuff. But since I've moved, I actually have now not had enough time to keep working on it. So I've kind of paused it for now. I got it up to a level where it works. I can mess around with it and get it to talk to a CNC machine. But it's not great and it needs a lot of work, but I don't have time, so I'm going to pause on this project and I just want to release what I have now, and I want to do a demo and just show you guys what it is, how it works, and all that good stuff. So this is it. I'm going to try and keep this pretty quick and just show you how it works and show you what I got. So firstly, I should say what it's called. It is called Axora. Axora? I don't know, I'm not sure. Name may change, but this is what I'm calling it for now. It's on my GitHub, so this is going to be public as of this video being released. So you can go here, you can go to github.com/KRI3/Axora, and you'll find all the source code. There's some stuff about getting up and running, and you can kick through here. There's a front end and a back end. It's all done in a monorepo style. The back end is a Rust app, which a bit niche, but it's what I wanted to build it in. So if you don't know Rust, I'm sorry, you might not be able to work on this yourself. Front end's a little bit more standardized. It is just a React, React TypeScript front end. Pretty standard stuff there, but yeah, it is quite nice. So yeah, that's that. This is what our homepage looks like. But let's run the app. It's not actually running right now, so I'll run it. I'll give you guys a little tour around it, and we'll click around, click some buttons, and I'll show you how it works and some of the little design decisions around where it's at the moment. So first thing, I'll run the back end. So this is, like I said, it's a Rust app, so it runs with cargo. Go cargo run dash bin, and it's Axora dash server. We'll kick it off. Yep, that's up and running. This uses it's basically a web server, which also runs some orchestration stuff in the background. It is running for all the web stuff. It's using Rocket, which is this is kind of standard output from Rocket. I have to say, I hadn't used Rocket before. Very nice framework. Really happy with using it. Then for the front end, I can just run yarn dev. That'll just run Vite for me, and yeah, that's running now on port 5000. So this port 5000, I'll just refresh the page, make sure we're all hooked up. All right, so this is what we get to. So if you were to imagine, if you had your machine set up, you would have, the GRBL device running that's built into your machine, and then you might connect something to it, either an old computer you have lying around or maybe a Raspberry Pi or something like that. So on that Raspberry Pi, you will be running the Axora backend, and then you'll hit a specific route, and that'll serve you this front end, which you can then load in any web browser. So you can load it on a phone if you want, or you can load it onto your laptop. So ultimately, all it means is that you can connect to the machine without having to have a wire connected to it. So at the moment, particularly for me, if I want to send stuff to my CNC machine, I bring my laptop out to my workshop and I plug it in with a USB cable. But then no matter how long the job takes, my laptop is just tethered to that machine the whole time. So the idea with this is that you install the software on like a Raspberry Pi or something, which is permanently plugged into your CNC machine, and then it does all the orchestration work. And your point of just interfacing with it is through the web browser. So it's not intended to be like a fire and forget or a remote management system. I absolutely would not encourage anyone to try and remotely operate their homemade CNC machines. There are professional quality solutions that exist to do that type of thing, far out of the realms of any hobbyists. You really do need to be at your machine to use it. But what it does mean is that if I have my laptop, I can set it up on my workbench. not necessarily right beside my machine, and I can kick it off, and then I can just not have it tethered to the machine, so I can maybe have it somewhere a little bit out of the way where it's not going to get covered in dust or whatever, that kind of thing. So anyway, let's just do a little demo of what the app does so far. So for this example, I have a little Arduino Nano setup here, which is running the GRBL firmware on it. So this is our stand-in CNC machine for this demo. It's just plugged in to my computer with a USB. Again, that would be connected to your Raspberry Pi or whatever in the ideal kind of use case of this. So on this page, can't really do anything as of yet. I have a little settings thing I can load up. This is sort of the main window, expands and controls, got the control panel, and then I've got a files window. I suppose I can show you the file window. So this is just a really simple thing. So this is how you get the G code onto the device itself, so onto your Raspberry Pi or whatever. Just click the upload button, you drag and drop a file in, and then these are some of the files I've already uploaded. So you see there's a timestamp for when they were uploaded, so a few months ago, and I can delete these as well if I want to get rid of them to free up some space on the machine. So yeah, that's just how I upload the code files. I can minimize that. Then let's click this button. They'll scan for the ports that are available, so it'll just scan for all the available serial ports. It's detected my Arduino here, so I can pick either the TTY or the CU one. So I'm going to go for the CU one. Doesn't really matter what you choose. And now we're connected. So if I go to the control panel, here we go. So this is the view that we're met with. There's a few things going on here. I might actually just zoom out a little bit. Yeah, to give us a little more space. So we have our console down here. So this is basically just a command console that directly interfaces with GRBL. So I can type in, say, the question mark command, and there I get a response back. So what that's doing is there's a WebSocket connection in the browser. So it sends that command to the running server. Then the running server is going to send that command over an orchestration pipe. It has an asynchronous channel that's connected to over serial to the device, pings that message, the response comes back, and it gets piped all the way back up to the WebSocket, which then renders here. Other things here, we can do some jogging stuff here. We have a start stop, we can set feed rates and that kind of thing. We have a status up here which displays the machine coordinates and the state that it's currently in, currently idle. And then this is our view of what we're doing. So you can zoom in, you can pan and rotate and all that sort of stuff. And this will show us the path that our machine is traced out when it's running. So let's kick off a run or a fake file and then see what it looks like. So I can go up here to my file selector, so you can remember the files that we uploaded here. So they're all available here in this drop down. So I can pick this one, and then I click the start button, and that will start the job. So what we'll see here when we start the job is a couple of things. We'll see this GRBL terminal start to just spit out responses, and so this is going to show us the back and forth send and receive of the responses to the GRBL device. And then we're going to see this little orb pick up and move around, and this will trace out the path that our machine is executing on. All right, so let's click the button. And there we go. So there's our things. It's too fast to read, so you're not really seeing anything interesting. So I can just minimize that. And then you see our little indicator is moving around, and it's tracing out this path. And you'll notice that it keeps, basically it sort of centers the camera view on the little moving bit or tool end, whatever it would be. And you can see we've got our coordinate system moving around here. You can see where the Z is at a -0.4. And this is an actual toolpath that I had. Tonlagee is the name of a mountain in Ireland, and this is kind of an abstract contour map of that mountain that I was engraving before. So because this is actually an engraving path, the Z is minus, so this would indicate that the bit is down in the work, currently carving out its engraving. So I can zoom out on this so you can see the picture a bit better, and you'll see here, if I kind of turn it around, you can see where the bit lifted up to its safe height, cleared, traveled all the way over here, and then dropped back down to its working, and then it's going to keep doing that. And yeah, that's like that's kind of it. Like, oh, got a bit crazy there. this is pretty much what it does. It's pretty much all it does at the moment. So with this tooling setup right now, I know I'm pretty confident that I can get my CNC machine with, say, an engraving job that I've done up in Fusion. I can throw the job, I can upload the G code onto the system. I can set it up on the machine. I can hit this button and I know it will execute this G code and it will show me the progress as it's going. And I can emergency stop. I can hit this button if I need to stop it. But again, as I mentioned, you should be standing at your machine, so you should really just slam your e-stop if that's what is, if you spot something actually going wrong. Shouldn't click a button and wait for some communication protocol to stop your machine. If you do have an e-stop button, you should use that. And yeah, that's kind of it. It took a lot to get here. It's actually quite complicated. A lot of different steps and stuff. A lot of different considerations that I didn't really have. One thing I will say is that AI was really helpful with this. Like professionally, I am a software engineer, so this is kind of my bread and butter. But I'm not the best at front end development, so I'm not great at React. This was really helpful for me, spinning up a whole React app from scratch. I was able to throw stuff at it, also finding that the LLMs for the coding assistants are quite good at front-end code. Not as good at back-end, but they're quite good at front-end code, so it's able to generate components and stuff for me really easily. And on the back end, there was a few bits that I didn't quite know the structure of in terms of like some of how concurrency and async programming works in Rust. I hadn't done it before, so the AI was really helpful to give me some pointers on how to set that stuff up and get it working. So pretty good use case there. Very happy. Rapid prototyping. AI is pretty damn useful for it. So yeah, really happy. And yeah, that's kind of it for this. I'd love to say this is the V1, just you wait, you're going to see all sorts of great, amazing things done with this, and this is going to become the best CNC software in the world. No idea if I'm going to work on this much more in the future. What I'll probably do is I will probably use it for the few jobs that I want to do, where I want to do some simple engraving stuff, which is kind of a lot of what I do with my current CNC machine setup, because it's not capable of much else. And yeah, if I decide that I want to do more, I'll do more. If not, I won't. Simple as that. But I think for my use case, this is going to be great for me, and I'm really happy with how this turned out. I got to finish off just with a little caveat that I do not think you should use this. I don't think this is something that everyone should use. It's also not really super accessible for everyone in the world. If you're not a programmer, if you're not a developer, you may find this really, really difficult to set up. You may struggle with just, making the stuff work. And yeah, so I wouldn't recommend this as a solution for everyone. Also, I cannot necessarily guarantee that this is perfectly safe or that it does exactly what it does. I've tested it somewhat and I think it does what I've tried to do it, but it hasn't been exhaustively tested, so there could be combinations of instructions or setups that just aren't reflected here, that I can't guarantee how well they work. So yeah, my advice is don't use this. But if you want to get a little bit of inspiration, go and have a look at the source code, have a mess around with it if you like. But yeah, my advice would be don't use this. I'd go and buy something off the shelf or find some open source project that's robust and is well tested and has been around for a long time, if you want to control your CNC machine. So yeah, that's the caveat I give. Aside from that, have a look at it, mess with the code, take a look, see if you learn something from it. Maybe there's something in there that you think is really interesting or not. Maybe you might learn something. I don't know. So yeah, I'm gonna leave it here for this little video. Pretty short for me. My standards, usually I ramble a hell of a lot more, but this is a pretty small thing. I just wanted to show it off, and just wanted to, I put so much work into this that it took me so long that I just want to show it, even if it doesn't end up going anywhere. So that's it for this one. Like I said, if you want to check this out, link in the description for the code on my GitHub. And yeah, if you made it this far, thank you very much for watching, and I will see you in the next one.